Hello, good morning, guys. Well, our last discussion was on friction last time, and just a quick review on friction. Friction is defined as a force that always opposes the motion of an object. It acts as parallel to the surface in contact and the opposite in motion. So its direction is always opposite to the direction of motion of the object. And friction can be computed. It's given by the empirical formula or based on experiment. The frictional force is just dependent on two quantities, mu and Fn. Mu is what we call the coefficient of friction, and Fn is just the normal force. Mu gives you the idea of the type of surfaces in contact, and Fn gives you the factor upon which the two surfaces are pushing each other. So friction is only dependent, or the magnitude of friction is only dependent on these two quantities. It is not dependent on the surface area. And we talked about example number 1 and example number 2 last time. So we now move on with example number 3. Example number 3, Marlo and Laggy are sliding a 3 times 10 to the power of 2 kilogram safe. So this would be the mass of the object across the floor to their getaway car. The safe slides with a constant speed. If Marley pushes from behind with a force of 3 times 10 to the power of 2 newtons, and Laggy pulls with a rope from in front with a force of 3 times 10 to the power of 2 newtons, what is the coefficient of friction between the safe and the floor? So we're given here that it's moving with a constant speed. So, and it's moving in the same direction. So we can say that acceleration is equal to 0. And remember that if the acceleration is equal to 0, the summation of all the forces is equal to 0 also. So at least based on that, we now have an idea that the object is not accelerating, as well as if we're going to take the forces, the sum of the forces, it gives us 0. So we're given also the in order it to move with a constant speed, Marlowe and Laggy should exert a force of 3 times to the power of 2 newtons and 3.9 times 10 to the power of 2 newtons. We want to get the coefficient of friction. So just like any dynamics problem, we can remember the first thing that we're gonna do is draw a free body diagram. So we're gonna check the forces acting on our safe. So we do the free body diagram of the safe, and again we can always represent any object with a dot. So that is my safe, and I'm gonna identify all the forces acting on that particular safe. One, we have the force of gravity, the weight of the object, which is given by the mass times its acceleration. And we also have the normal force, and Marlowe and Laggy, let's say for example the object is moving to the right, so the applied force should be at the right. So this is the force exerted by Marlowe, which is equal to 3 times 10 to the power of 2 newtons. And Laggy is also applying a force with a magnitude in the same direction, 3.9 times 10 to the power of 2 newtons. And there should be another force in order for this object to be moving at a constant speed to the right. And that particular force is the frictional force. So remember that our object is moving to the right, so frictional force should be in that particular direction. And we don't know about this one. So if we're gonna solve for the weight of the object is given by the product of the mass and the acceleration due to gravity. So this would give us product of 294 newtons. So that's the weight of the object. And now we already identify the forces acting on the object. We want to get the value of mu. So mu is the unknown. So to start with our solution, we know that to get mu is part of the friction equation. So frictional force, the magnitude of the frictional force is given by mu and multiplied by the normal force. Or from there, we can have mu is equal to F over Fn. So in order for us to solve for the coefficient of friction, we have to get the value of the frictional force and the value of the normal force. So let's say, for example, we want to solve for the frictional force. So frictional force. Now, if we're gonna look at our free body diagram, that's why we always start with free body diagram. Frictional force is acting along X. So if remember that the acceleration here is equal to 0. So that means that the sum of all the forces along X is equal to 0. So that means that you're taking the sum of all the forces along X, and that should give us the 0. So that would be my starting. Remember that friction is acting along the X axis or X direction. So we have here summation of all the forces along X is equal to 0. So I'm talking about the forces there. So along X, to identify that, it's given by FF, FL, and FM. So I have here FM, it's one of the force, plus FL, then plus the negative of FF. And if I'm gonna take the sum of all of those forces, it gives me 0. Remember that FF is negative because it's the opposite direction. Remember that these are vectors. So you have to take note the direction. So we have here, if we're gonna solve for FF, so Fm is given by 3 times 10 to the power of 2 plus FL is given by 3.9 times 10 to the power of 2, which will give us, so if I'm gonna transpose FF to the other side, that gives me FF. So the magnitude of FF is just given by the sum of these two, which gives us 6.9 times 10 to the power of 2 newtons. That's the magnitude of the frictional force. Okay, so the magnitude of the frictional force is given by this. So now, therefore, if we're gonna go back to our mu, FF is given by 6.9 times 10 to the power of 2 newtons. Now, at least in that particular case, we already determine the magnitude of our frictional force. However, in order for us to solve for mu, we need to solve for Fn. So we need to solve for Fn, or the normal force. Again, the normal force is the quantity in our friction equation that tells us how hard the two surfaces in contact are pushing each other. So Fn is acting along the y-axis, or at least the vertical forces. So again, the forces along y is equal to 0. So which gives us the idea that the summation of all the forces along y is equal to 0. That means that if we're gonna take the sum of all the forces, the vertical component of all the forces, it gives us 0. So if we're gonna expand the forces along y, well, I'm gonna go back to my free body diagram. There are two forces that is acting along y, and that is Fn and Fg. So I have Fn, which is upward, and I use the convention that going up is positive, and plus, so therefore Fg is negative, and it gives me equal to 0. So if you can see here, Fn is just equivalent to Fg. So the normal force, therefore, is just equivalent to Fg, which is 2940. So it's given by this. So Fn is 2940 newtons. So that would be 2940 newtons. So if you can see here, Newton is cancelled out, and mu, remember that mu doesn't have any unit. It's just a pure number. It's just a number. And if you're gonna divide that 2, it's 6.9 times 10 to the power of 2, or that is 690 newtons. So that is 690 newtons divided by 2,940 newtons. And that gives me 0.235. Again, it's just a pure number. It's just a number. And that's my answer. So in 3 significant digits. So if you can see, I started with the free body diagram. That's always the case. It's much easier for you to get the solution if you're gonna do it first with the free body diagram.